ça se passe. Je rappelle que les images que vous avez actuellement sur votre écran ne sont pas des images vidéo, hein. C'est une photo qui a été prise hier, non pas hier, c'était le moment où l'Ariane 5 roulait vers son pas de tir. Alors on va prendre d'autres questions. Alors il y a Valkyria qui demande pourquoi le nom de JUICE. Alors le nom de JUICE, déjà parce que c'est un nom rigolo, mais aussi c'est une contraction de Jupiter Icy Moon Explorer. Donc l'explorateur des lunes glacées de Jupiter. C'est très et l'arrivée à Jupiter. Ça va être extrêmement long. Je vais vous remettre l'infographie de la trajectoire. Hop. Non, toujours pas. Non, toujours pas. Si, c'est bon. On va y arriver. Donc là, vous avez l'infographie en accéléré de Jupiter. Je vous en ai des comptes à rebours, comme ça vous aurez les dates. Donc là, c'est la première année, donc premier tour de Soleil. Vous voyez qu'elle est partie de la Terre. Là, elle repasse. Et là, elle fait une assistance gravitationnelle pour s'accélérer. Elle passe d'abord la Lune et puis la Terre, donc ça va faire une double influence, et ça c'est la première fois que ça arrive. C'est une manœuvre qui n'a jamais été tentée. Ensuite, elle va passer par Vénus, où là Vénus va de nouveau l'accélérer, là aussi. Le tout avec à peine quelques grammes de carburant, hein. C'est ça qui est fou. Ensuite, elle fait un troisième tour de Soleil. On est entre 2025 et 2026, où elle passe de nouveau proche de la Terre, mais pas proche de la Lune. Donc la Terre l'accélère encore une fois. Elle refait un tour.
To simulate on Earth is the same gravity as on Mars, that is 1/3. So we created a ground support equipment, that is the rover floating device, that basically pulls the rover of 2/3 of its weight. And through that we were capable to really demonstrate the functionalities of mobility and drilling in a representative environment.
The next day, the drilling test is finally ready to begin.
Okay, Daisy Rock, we are ready to send the commands to collect the sample at 1.7 meter depth. I will give it on my mark, so 3, 2, 1, mark.
The Earth Twin rover will try and drill into a clay stone at a depth of 1.7 meters, much deeper than anything other rovers have ever attempted on Mars. Such a depth will offer access, it is hoped, to organic material from 4 billion years ago, when conditions on the surface of Mars were more like those on infant Earth, enough to make engineers feel a bit nervous.
So this is the control room where engineers and scientists are sending commands to the rover and receiving its data back. And as you can see from the number of people and computers, there's a rather large amount of information to handle.
Daisy Rock, can you please report the execution of the command status, please? We are standing by.
The test is conducted in real time. Commands are sent to the rover, but it takes hours before it starts moving, the same time it will take for data to travel from Earth to the Mars surface. After many hours of commanding and data analysis, the drill is finally retracted. The sample is then dropped into a drawer, which withdraws and deposits it into a crushing station. The resulting powder is distributed to ovens and containers to perform the scientific analysis on Mars. The rover is a real laboratory on wheels.
It has been a very long test. The tests are successful. We have at 1.7. We have been able to take it.
澎湃新闻的网友，大家好，我是王瑞。现在我们画面中看到的是位于法属圭亚那的太空中心。在今天的稍晚些时候呢，欧洲航天局领导的木星冰月探测器即将在这里发射升空。现代宇宙航行学奠基人康斯坦丁·齐奥尔科夫斯基曾经说过，地球是人类的摇篮，但是人类不能永远地生活在摇篮里。人类其实自远古时代开始就对浩瀚的宇宙有着无尽的想象。进入到20世纪之后呢，随着科学技术的进步，人们借助月球、火星、金星等各类的行星、小行星，包括卫星探测器，逐渐揭开了宇宙神秘面纱的一角。那在4月13号，也就是今天，欧洲航天局领导的木星冰月探测器即将发射。计划的发射时间呢，是在北京时间的今天的8点15分。如果一切顺利的话，航天器将在2031年抵达气态巨行星。它的主要目标呢，是研究木星及其3颗最大的卫星，这个木卫2、木卫3和木卫4。冰月探测器在飞往木星期间，将利用地月系统和金星引力弹弓进入木星系统，将于2031年进入环绕木星的轨道，并在4年的时间内对木卫2、木卫3和木卫4进行多次的这个飞掠探测。飞掠任务完成之后呢，冰月探测器将进入到太阳系内最大的卫星木卫3的轨道，它也将成为人类有史以来第一个进入另一颗行星卫星轨道的探测器。并且木星冰月探测器的任务呢，将探测整个木星系统，并且有望揭开木星的卫星是否存在生命和让微生物生存的条件。那木星任务呢，其实每天只有1秒钟的时间可以发射，并且到达正确的轨道。这将在8年内呢，将其带到这颗气态巨行星。这艘2.67吨的航天器带着4吨的燃料出发。尽管航天器的设计者也承认了说这是大量的燃料，但他们希望可以尽可能多的节省这些燃料，以便这个冰月探测器在其目的地的时候能够进行许多的机动。详细研究木星的4个主要卫星中的3个。这一次的木星任务的发射时间呢，其实比大多数其他航天器更为紧凑，因为就像我们刚才提到的，它每天只有1秒钟的启动窗口。航天器将飞越金星、地球和月球，来提高其速度，并调整它的轨道。但是呢，要做到这一点，这些天体必须正确的对齐。那这种情况呢，每年只发生2次，一次是在4月份，另一次就是在夏末。因此，在1秒钟的这个窗口内，科学家必须要在太空中的某个点注入航天器，使其处于继续飞行并执行飞跃的首选路径上。那接下来我们来关注一下发射当天场地、设备还有天气的一些情况。那我们首先来关注一下有关于天气。现在的天气预报显示呢，4月13号，也就是今天，当地的天气是比较阴沉的，而且还有一些雷暴，预计下雨的可能性是76%。那么这样的天气是否会影响发射呢？那这个团队啊，在4月6号的简报会上就做了一个分享，说他们一直在实时的监测着天气预报，特别是发射前几天。那么今天已经来到了发射的当天，天气的预测和监测仍然在进行当中。那么如果任务因为天气或者是技术原因推迟了，那么团队可以在当月，也就是4月份剩余的时间，每天再尝试发射一次。虽然欧空局呢尚未宣布一个具体的时间，但是发射的窗口，刚刚我们提到的每天1秒钟的发射窗口，都在每天的不同的时间。所以团队在周次的简报中是这样的分享：如果航天器没能在4月份发射，那么下一个可用时段就是要在4个月之后，也就是2023年的8月份。关于此次发射的场地，这一次冰月探测器发射任务将在法属圭亚那太空中心进行， 而欧洲航天局啊，几乎所有重要的航天发射都是在这一太空中心进行的。作为一个航天大国，法国在航天领域的重要地位不仅体现为拥有极为理想的航天发射场，曾占据了像商业航天发射市场的半壁江山的阿利亚纳火箭也是由法国主导研制的。那法国在空间应用方面的贡献同样也是不容忽视的。在上世纪的80、90年代，法国研制的低轨道的商业对地遥感卫星也是领先于全世界。这些卫星呢，面向商业市场开放，推进了遥感技术在民用领域的应用。那刚才我们说到的由法国主导研制的阿利亚纳火箭，本次发射呢就是使用到了阿利亚纳5型火箭，这是阿利亚纳系列火箭中的最新型号。那关于本次的探测器是冰月探测器，重约6吨，搭载了透冰相机、光谱仪和雷达等10余台科学仪器。冰月探测器呢，也配置了一个85平米的太阳能电池板，这也是迄今为止深空探测器中最大的太阳能电池板。冰月探测器在2023年的4月1号抵达了总装大楼之后，它被缓慢地提升到空中，然后小心翼翼地下降到了这个阿利亚纳5号火箭的顶部。现场的工作人员呢，通过我们看到的现场的一些图片发现，工作人员来到了火箭的顶部，用这个螺栓固定探测器运载火箭的适配器，来确保其在发射过程中的安全。这一次的任务是要用8年的时间去到木星，其实对木星系展开探测是具有重要意义的。木星呢是太阳系中最大的行星，也是太阳系中的气态巨行星。它的质量是地球的318倍，体积是地球的1317倍。木星的大红斑是太阳系中最著名的风暴，它已经持续了至少350年了。350年的这个时间比人类文明历史还要长。此外呢，木星还有许多的卫星，其中最著名的就是这个伽利略卫星。木星在太阳系中的地位非常的特殊，那除了刚刚我们提到的最大的行星，同时呢，它的质量是超过了太阳系中除太阳外所有天体的总和。曾经有一种说法认为说，如果太阳系中没有太阳，那其他天体都会围绕着木星旋转，因而呢，木星系又被称为小太阳系。同时呢，木星其实也是极其复杂的，即使已经发现了数十颗围绕木星运转的卫星，但是即使到了今天，仍有许多未知的木星卫星在等待我们的发现。 曾有专业人士就指出，木星最大的4颗卫星各有特点，而且都极具探测的价值。比方说像木卫2，它的水资源的总量超过了地球上所有海洋的水量，甚至有观点认为呢，这些覆盖于厚冰层下的水资源可能存在原始生命，足以见得对木星系开展研究的重要性和必要性。可惜的是呢，尽管人类已经发射了多个木星探测器，但当前我们所掌握的木星探测数据仍然是非常有限的。以往成功发射的这些木星探测器中呢，部分探测器都是在飞掠木星的过程中对其进行探测，无法实现一个长期的探测。还有部分的探测器呢，虽然进入了环绕木星的轨道，但与木星卫星擦肩而过的机会极少，收集的数据也不多。所以此次的冰月探测器将成为第一个环绕木星的卫星运行的探测器。只有进入环绕卫星运行的轨道，探测器才能连续获得大量的探测数据，而且要实现这一个目标，难度是非常非常大的。探测器呢，进入到这个环绕木星的轨道，需要耗费非常大量的推进剂，而后呢又要变换轨道，进入环绕木星卫星的轨道。这一过程呢，需要再次制动，是对工程和技术的一次巨大的挑战。
There she is, the Ariane 5 rocket standing tall on her launch pad here at Europe's spaceport in French Guiana. with her single passenger today, the Jupiter Icy Moons Explorer. JUICE safe and sound under the fairing, ready for liftoff in just under half an hour. I'm here in the Jupiter Mission Control Center, and we are some 12 kilometers away from the launch pad. And here, on the other side of this protective wall, which we call the fishbowl here in Jupiter, you can see the operational teams hard at work getting ready with the last preparations for today's launch. Opposite me here, we have partners, VIPs and guests, all waiting for liftoff, comfortably seated. And they are among the happy, well, the very lucky few who will get to see the liftoff with their own eyes. They'll feel it as well from the terraces on either side here of Jupiter. And I'm very happy to welcome Stéphane Israël, CEO of Arianespace. Welcome to Rotor Space, Stéphane.
Good morning, Liz.
So you're here to give us an update on the situation, but first of all, a very, very special mission today with an outstanding passenger under the fairing of Ariane 5.
For sure, JUICE is an outstanding mission. I mean, this mission has involved more than 21 partners around ESA and Airbus Defence and Space. And so today is a very important day for us because this mission is a unique mission towards Jupiter. It is the start of an 8-year journey.
And is this type of mission a particular challenge for your teams here?
So this is a 30th scientific mission Arianespace is going to deliver for ESA, and the most recent one have been James Webb and before Bepi Colombo, so we know how to deliver them. But it is an escape orbit, so it means that after 27 minutes of flight, we will have given to the JUICE a speed of more than 10 kilometers per second to allow JUICE to escape from the Earth attraction. So this is what we are going to deliver today.
And what's the situation looking like at the moment? I can see everything is green on the status board.
Yes, so everything is green, and so to lift off, you need 3 parameters to remain green up to the very end. The launcher should be ready, and up to now the launcher is ready. JUICE should be ready, and up to now JUICE is ready. And the final parameter, which is very important, is the weather. And we will make 2 last checks for the weather, 20 minutes before the launch and 10 minutes before the launch, and we will see what will be the situation at this moment.
Thank you so much, Stéphane. I'm going to let you get back into the fishbowl where you're heading up the flight desk, and we'll speak to you right after separation. Thank you so much.
Thank you, Liz.
So, of course, launch operations are underway here, final preparations, but some 7,500 kilometers away, over the Atlantic, in Darmstadt, Germany, at the European Space Agency's Mission Control. The operational teams that are going to take over control of the spacecraft once it's separated from the mothership are on standby. And we're going to go straight over to Darmstadt and hear how things are going over there. Over to you, Matt.
Thank you, Lisa, and hello to our watchers. Welcome to ESOC, the European Space Operations Centre facility here in Darmstadt, Germany, in the heart of the Mission Control Centre of Operations. My name is Matt Russell, and I'll be your host for this second half of this really special JUICE broadcast. And behind the glass here, we have our resident expert, Bruno Sousa, who is a Deputy Flight Director for JUICE. Hello, Bruno. Can you give us an update of what's exactly happening now in the mission control?
Thanks, Matt. Everybody's getting goosebumps over here. Just a few minutes ago, Flight Director Andrea Komatsu gave us a roll call, and I think we have footage of that, and we're going to show it to you right now.
To all stations, this is Odi on the briefing loop for the roll call of the JUICE mission. Please reply to my call with your call sign and status go or no go. OM.
OM.
Go. SOM.
SOM go.
Data handling.
Data handling go.
AOCS.
AOCS go.
Platform.
Platform go.
Flight dynamics.
Flight dynamics go.
Project rep.
Project rep go.
Project support.
Project support go.
Softcode.
Softcode go.
Software support.
Software support go.
STRAC.
STRAC go.
Scheduling.
Scheduling go.
Thanks. This completes the roll call for JUICE. We are go for launch.
So we're all ready for launch, just waiting for the rocket to get out of the launch pad. Back to you, Matt.
As you can see, everything's ready for launch. Over to you, back over to you, Lisa, in Kourou.
Very much, Matt. and it was great actually to see people whooping here as they heard that everything is ready to go. So we heard it from ESOC. Operational teams are ready over there. The spacecraft is ready here in Kourou. But what about JUICE? Well, I'm with Mihaela, and you're going to tell us from ESA, and you're going to tell us how is JUICE doing? Is JUICE ready?
Morning, Lisa. Yes, JUICE is ready. As the project team, we are so ready. It has been years since we have been waiting for this moment, and we are all very excited. As we speak, my colleagues are a few kilometers away in LBC control room, and yesterday evening at 7:15 p.m. the satellite has been switched on, and together with the flight operators, we are closely monitoring it as we speak. It has been quite an intensive launch campaign, but we are in excellent spirits, and we are excited to watch JUICE starting its journey today towards Jupiter and its icy moons as planned.
Fantastic. You say as planned because your role is schedule controller, a huge responsibility. Does that mean you're in charge of making sure it takes off as planned?
Part of my responsibility, yes. But when you speak about scheduling in the agency, it's not one person's job. Actually, it's a team exercise. And thus, the JUICE project team, we are so schedule-oriented. We have a strong planning mindset. And if you take a step back and you look at the impressive mission we are seeing today, you have 10 state-of-the-art instruments, you have an impressive spacecraft, you have the most large solar arrays ever flown for an interplanetary mission, 85 square meters. Then you translate all this information to milestones, you understand how much work it takes and how much excellence in project management.
Mihaela, when we spoke earlier, you told me this is 8 years of your professional life. How are you feeling today in a nutshell?
I'm so excited because, honestly, for me, JUICE is my entire career in the agency. I was shortly assigned to this mission when I joined, and I am exceptionally proud to be part of this team. And I want to say have a good launch to all my colleagues here on the spaceport, my colleagues watching now in Aztec, my colleagues in ESOC, which are working, and my colleagues in ESAC. Have a great launch, everyone. We all worked hard for it, and we all deserve it.
You absolutely do. Thank you so much for being with us, Mihaela. And so, as Mihaela was saying, so many years of work for her teams, for teams around the world. So we're going to take a look at their achievements, and we're going to meet our passenger in this next film.
And last but not least, the formation of Jupiter and its moons. JUICE will also study Jupiter's complex weather, chemistry and climate in detail.
It's a very fantastic mission from the scientific point of view. Very broad science, very interdisciplinary science. We would like to see whether around Jupiter there are places where life could have started. To explore that, we need to find a place with internal energy and with liquid water. And inside the icy moons, we have good reason to believe that there is in fact more liquid water there inside the surface than on Earth.
JUICE is expected to arrive at Jupiter in 2031 and will then make its Jupiter tour and moon's flybys before orbiting Ganymede. This will be the first time a spacecraft orbits any moon other than our own. During its journey, JUICE will face many dangers such as Jupiter's intense radiation belts or its large gravitational pull, but these dangers will be worth it for the science that JUICE will uncover. The gas giant will reveal some of its many secrets in 2032 when the first data will be available. Watch this space.
And back to us here in Kourou. So, talking about explorers, we have two of the faces of space exploration with us here today. And I'm very pleased to welcome two of Europe's most experienced astronauts. We have Matthias Maurer and we have Thomas Pesquet with us here today. So my first question is for you, Matthias. It's all very well, sending JUICE out there, but when we go out there to space, send, spacecrafts like JUICE, what does it bring us back here on Earth?
I think at the beginning of everything is the human curiosity. We humans, we want to understand. When we fly to space, we want to understand and learn. It's also applicable in science and technology in general. And once we understand, we want to translate it into applications, see like how can we make our life on Earth easier, better, with the knowledge that we gained in space. And so all the stuff that we do in space, it directly feeds back into applications. Just looking at the huge solar panels of the probe 85 square meters. It's like today we are talking about green energy to have life on Earth more sustainable. Without solar panels developed for space and then spin off onto Earth applications, this transformation in energy for Earth applications would not be possible. And I mean, sometimes it takes longer, sometimes the application will come years after the science has been done. So thanks to Einstein's relativity theory, we have now the best navigation system in the world, the Galileo system, and everybody can use this with a mobile application in their hands.
Thank you very much. So we're sending JUICE out on its journey today, but what about the upcoming destinations for human space exploration?
Yes, so we humans, we can unfortunately not yet travel such large distances to Jupiter. So we fly to low Earth orbit, the International Space Station, and once this will end, we will continue with new, more modern platforms. But then we also continue exploration. We are part of the Artemis program. ESA is an essential part of NASA with the European Service Module. So we will be flying to the moon, and Thomas and I and our colleagues from the astronaut corps, we are dreaming of flying the first Europeans to the moon, being among them, hopefully stepping also on the planet. And it shall be a continuous presence on the moon. And on moon we will learn a lot for technology that we spin back to Earth applications, but we will also learn for later on for missions to Mars.
So talking about, going to the moon, I mean, Thomas, are you getting ready to, take part in any of these missions that Matthias is telling us about?
I think we are. I think ESA made the bold decision to send Europe onto this adventure, which was the right decision to make. I think we have a variety of destinations today. We should not forget low Earth orbit and the International Space Station. Our friend and colleague Andreas Mogensen is now in the final stretch for his mission, launching in August. And then we'll have a rotation of missions to low Earth orbit. We have new colleagues who have just started at the European Astronaut Center, and we're glad to have them. There's going to be so many missions to fly in the future, and obviously the Artemis missions. Everybody's trying to, do their part. Everybody's trying to contribute what they've learned in space, what they've learned before, to go as a team, and that's what we're focusing on for the years to come.
So I hear the two of you telling me that you're both able and ready to go. Do you see yourself taking off from Europe's spaceport here in French Guiana, Thomas?
I think it'd be a dream, but it's more than a dream because we're having this conversation. We're working on this independent, access to space for humans from French Guiana. We have all the building blocks. We've had a reliable launcher, Ariane 5, Ariane 6 is going to follow suit. We've had the ATV, the transfer vehicle. We've had the CRV, the return vehicle. We have Space Rider. We have everything. We have all the building blocks. We just have to put them together. And for this, you need a vision. I think we have the vision. Now we need a mandate. But tomorrow, you can imagine, now that Europe is more mature, now that Europe is, growing on the scene, people feel more and more European, sometimes because of the crisis around us. But at least the result is we're being more united. And I think that would be a fantastic project to kind of inspire Europe and to channel the best that Europe has to offer and to make Europeans dream for generations to come.
Gentlemen, thank you very much. Stay with us because we have Josef Aschbacher. Josef, thank you so much for joining us. You are ESA Director General. Well, a very simple question to you. I mean, we're talking here about, the capability of space explorations. Are you going to make this happen? Human space exploration, of course.
I mean, it needs a lot of people to make this happen, but of course, my job as Director General of ESA is to make sure that the discussion takes place and that we have a discussion in Europe and preparing decisions in order to make this happen. In fact, we just received a report from a high-level advisory group called Revolution Space, and that really means a revolution for Europe in space to really engage, bring Europe one level higher in space exploration, literally, and make sure that Europe has all these capabilities which Thomas and Matthias have just described. So yes, we're doing everything to make it happen. But Lise, today we're here in front of the screens of JUICE. Let's talk about JUICE because that's such an exciting mission.
Thank you so much, Joseph. Thank you, Thomas. Matthias, thank you very much for being with us. It was a pleasure.
Thank you.
So for those of you who are joining us, we are just under 12 minutes to liftoff. And I'm here in Jupiter Control. We're about to see Ariane 5 take off with JUICE under its fairing, heading for Jupiter. And I am here with Raphaël Chevrier from Ariane Space. Raphaël is going to take us through every step along the way of this mission. Welcome to Road to Space, Raphaël.
Hello, Lise.
So why don't you take us through maybe the next steps coming up now?
Oh, absolutely. So Ariane 5 this morning is going to launch towards the east. So at such low latitude, we benefit from what we call the slingshot effect given by the rotation of the Earth, providing enough speed for JUICE. The launcher first performs a pitch maneuver to get into the required direction, and only 2 minutes and 17 seconds after liftoff, the two boosters have done their jobs of providing enough the main thrust, and they are detached from the launcher. And shortly after that, the fairing, which protected the spacecraft from the frictions of the air, is separated in two halves as we have crossed the limits of the atmosphere. We just don't need it anymore. And once the launcher reaches an intermediate orbit, the main stage is cut off and separated. We then enter the second proper phase of the flight with the ignition of the upper stage. The engine powers for about 16 minutes in order to raise speed and altitude and reach the targeted orbit for JUICE. The little towers that we see on the motion picture represent a chain of telemetry stations that are receiving data from Ariane 5 all along the flight path. And after some orientation maneuver, JUICE is separated on a liberations orbit, meaning it will have the required speed to escape the gravitational pull of the Earth. This is almost the end of the mission for the launcher perspective, as we still need to perform some disposal maneuvers of the upper stage, but this is definitely the beginning of the journey for JUICE. ESA teams will use the North Sea ground telemetry stations in Australia to acquire signal from the spacecraft and take full control of it.
I think I'll take over from here, Raphael, because I can actually hear...
There's an announcement here.
Yes, an announcement here. We're bringing you this information live. I'll actually listen to what's being said in French and I'll come back to you and translate. Sounds like we're heading for...
There is a risk of lightning right here.
Yes, a weather.
The weather is quite challenging.
Right, it's been announced. So Marianne Claire has just announced that we're going to halt the launch operations for now, for today, due to weather conditions. But what does this mean, Raphael?
So it means that we usually check whether it's, the winds at high altitude, the winds in the vicinity of the launch pad, and also the risk of lightning. This is the latest criteria that is not suited for a launch today. Unfortunately, this is out of our control, but it also reminds you that we don't take any risk when it comes to launching a satellite into space.
Absolutely. So as Raphael was saying, it has been announced that for today, the liftoff is going to be postponed. Of course, our passenger is safe and sound under the fairing, and we'll, of course, be bringing you all the information on a new date as soon as we get it. We have Stéphane Israel, who is going to come and make an announcement to us right now. Stéphane, welcome back. So
yes, thanks.
Faster than we had imagined.
Yes.
But it's beyond our control, right?
Yes, for sure. You know, it's part of our business, and what is important is when you lift off, you must make sure that all the parameters are green. Again, the launcher was okay, JUICE was okay, but the final checks made by CNES on the weather were not okay. You have two reasons not to lift off: high altitude winds or risk of lightning. The high altitude winds were okay. There was a risk of lightning, so now you see red on the screen. What is important is that the launcher and JUICE are in stable configuration and in full security. We will be back tomorrow morning, a few seconds before we aim at lifting off at 8:14 Washington time, 9:14 Guyana time tomorrow morning.
Well, there we go. So Stéphane has actually given us the news here live. So the next date is tomorrow morning, and of course we're going to just bring that time forward by 1 minute. We were due to take off at 9:15. It's going to be 9:14, as you said.
Exactly.
So we will see you all tomorrow at more or less the same time, and we'll hope that the weather is going to be more clement tomorrow.
A little bit of patience, and it will be okay tomorrow. Yes.
Well, thank you very much, Stéphane, and be assured that JUICE is safe and sound under the fairing. It's just going to have to be a little more patient. Another 24 hours, let's hope. And that's it from us. Thank you, Stéphane.